Hey everybody, this is Michael with Systems of Human Performance. Today I'm doing another read-along of one of my recent articles titled Organizational Experimentation: How to Create the Discipline of Daily Experimentation. Experimentation is one of the main features of my philosophy in systems-based management, so I think this is a seminal article, and please take the time to read it or listen to this read-along. Strategy, vision, execution. These are the words that fill conference rooms and annual reports. They suggest a world where leaders see clearly, plan precisely, and organizations move in a straight line from decision to result. It is a comforting picture. It is also mostly wrong. Organizations are not machines that respond predictably to a lever pulled at the top. They are complex, adaptive systems, webs of people, incentives, habits, technologies, and feedback loops that interact in ways no org chart fully captures. The larger and more interconnected the system, the less confidence you should have that any single change will produce its intended result, no matter how good the strategy deck looked. This, of course, is the antecedent belief that gives rise to systems thinking. We cannot understand the behaviors of complex and interconnected systems by searching for root causes or breaking things down into constituent parts. If cause and effect in an organization are rarely linear, prediction alone cannot carry the weight leaders ask it to carry. What you need is a way of learning what actually happens when you change something before you commit the whole company to it. That way of learning is experimentation. So here, just to kind of highlight what we're talking about, is the way organizations typically function rely on something like prediction or root cause analysis or analysis by breaking things down and dissecting it into constituent parts. And what we're saying here is, as systems become more interconnected, and as really we understand and realize the reality of this interconnectedness, this normal functioning of management through dissection and analysis and prediction is manifestly incorrect and is manifestly not sufficient to get us where we need to go. What we're trying to put in place now is this thing of experimentation, of kind of probing reality, probing the environment, and seeing what comes back. This piece argues that experimentation should not be a program, a phase, or a task force assembled once a year, but rather be a daily operating discipline of the organization, the mechanism through which the system learns about itself and adjusts. To make that case, we will look at how systems thinking explains why experimentation matters, walk through a three-phase cycle that turns experimentation into an iterative, repeatable discipline, and pull case examples from organizations that built experimentation into their routines rather than their calendars. These are organizations like IDEO, Skunkworks, Toyota, Amazon, 3M, and Intuit. Why systems demand experiments. W. Edwards Deming, who is the patron saint of quality management, the statistician who helped rebuild Japanese industry after the war, spent much of his later career trying to convince managers of an uncomfortable truth. Management changes the system with nearly every decision it makes. Decisions alter the interactions, feedback loops, and constraints that make up the organization. None of these effects are fully knowable in advance because the system is too interconnected. Experimentation is the safest way to find out what an intervention actually does before it gets rolled out across 1,000 people. Deming made a sharper point in one of his later books, The New Economics, and it is easy to read past. Experience by itself teaches nothing. Someone can work inside an organization for 20 years, and without the requisite theory to test against reality, they can learn almost nothing generalizable from that experience. Knowledge comes from making a prediction, comparing it to what actually happens, and revising the theory accordingly. That comparison, prediction against observation, is the whole of experimentation. Whether it takes the form of a randomized controlled trial or something as ordinary as trying a new meeting format for 2 weeks and watching what happens. So this is a very important concept of one of Deming's later works and part of his system of profound knowledge. It's this idea that learning and the theory of knowledge comes from theory itself, right? We have to not just have data, we can't just have experiences. We have to have like a context to put these data and these experiences in place in order to learn from them. And experimentation is the mode to do that. This experimentation for organizations is the best place to start and end, really, at exploring your own individual context and finding meaning through trial and error in experimentation. And of course, testing assumptions and figuring out whether or not those assumptions are valid or under what conditions and circumstances they are valid. Systems thinking adds one more piece to this. In a complex system, an unexpected outcome is not a failure to be buried in a post-mortem nobody reads. It is information. It tells you something about the system that your mental model did not account for, like a hidden constraint or variable or feedback loop or some dependency that was never previously identified. Again, this is this idea of testing your assumptions and understanding under what context these assumptions are true. Treating variation as data rather than embarrassment is what separates organizations that actually get smarter over time from organizations that just get busier. And because systems never sit, there is no such thing as a finished organization. Optimization is not an event you complete and then leave behind. It is a habit maintained indefinitely through small, continuous tests against a target that keeps moving. A 3-phase learning cycle. This is a new framework I'm developing, and I'm putting it out here now. I think it's pretty good, but if you're listening to this or reading along and you think you could improve this somehow, I'm really interested in your thoughts on this 3-phase learning cycle. If experimentation is to become a daily organizational discipline, then it needs a repeatable structure which can be taught and developed into habit. Failure to do this will mean experimentation will always fail a longitudinal test. It will never stand the test of time, so to speak. Organizations that have institutionalized experimentation will tend to move through a recognizable and iterative 3-phase cycle. Phase 1, current state knowledge. The instinct in most organizations when something is not working is to jump straight to intervention and redesign. Many of the best problem-solving methods, like Lean and Six Sigma and others, identify this deficiency and propose a deep understanding of the current state instead. In this regard, the 3-phase learning cycle is no different. Indeed, the best place to start is with a goal of understanding and a deep inquiry into what is actually happening. Again, we can kind of look at experimentation and say, okay, we need to really understand the current state. This means going to see the work where it happens. Lean people will call this the Gemba. It means mapping the real process instead of the approved one. Value stream mapping gets into this, high-level process mapping in the Six Sigma discipline. Measuring cycle times and queues and defect rates and paying attention to the handoffs and communication patterns that never appear on an organization chart. It is a slow, unglamorous work, and it is tempting to skip it. But no one can experiment intentionally on a system they do not understand, any more than a doctor can prescribe treatment without first taking a history. Skipping this phase is how organizations end up solving problems that were never the real problem. Phase 1, current state analysis, deep understanding of what's actually happening. Phase 2 is improvement. Once there's an honest model of the current state, hypotheses about how to improve it can be generated, and this is where things like low-resolution prototyping earns their keep. The goal in this phase is not a polished solution. It is a cheap, fast, disposable test that shows whether a hypothesis has any merit before real resources get committed to it. Famously, IDEO, which is like a product development firm in Silicon Valley, built its entire design practice around this idea. Rather than debating the merits of an idea in a conference room, IDEO's default move is to build something, often something rough made of cardboard, foam core, or sticky notes, and put it in front of real users within days, sometimes hours. The famous ABC Nightline segment where IDEO redesigned a shopping cart in 5 days is remembered as a stunt, but the underlying discipline is what matters. A low-fidelity prototype answers questions a meeting never will, and it answers them faster and cheaper than building the real thing. So I'll just highlight here. I'm going to go through a number of different disciplines. We can talk about lean improvement, Six Sigma improvement, and using data. Talk about IDEO, which tends to use something called design thinking or human-centered design. We'll look at Lockheed Skunk Works in a second. The whole idea here is that after a current state understanding, we are now in a position to improve. We shouldn't worry about optimizing that improvement. We should instead worry about getting kind of those, what we would call the main effects, moving that needle as much as possible and really challenging any assumptions that get in our way of what we perceive the improvement to be. Optimization and fine tuning is going to be phase 3, which we're really going to get to in a second. Lockheed Skunk Works show the same principle at a very different scale and with far higher stakes. In 1943, tasked with building America's first operational jet fighter, Kelly Johnson put a small team of engineers into a rented circus tent next to the Burbank plant, stripped away the usual layers of bureaucratic approval, and gave the group direct authority to design, build, and test. The Army asked for a prototype in 180 days. Johnson's team delivered the XP-80 in 143 days. What made that possible was not only talent, I do believe they were called the Whiz Kids, who were part of Skunk Works, but it was also the organizational structure built to shrink the cost and time of finding out whether an idea actually worked. Small teams, tight feedback loops, and minimal bureaucratic distance between an idea and a test became the template Skunk Works used for decades of programs that followed, from the U-2 to the SR-71. Toyota offers a different lesson, that experimentation does not need to be reserved for special projects at all. The Plan, Do, Check, Act cycle, PDCA, Deming would call it the PDSA, Plan, Do, Standardize, Act cycle, and the daily practice Toyota calls kata, treat experimentation as something every employee does continuously, not something a special innovation team does periodically. A worker on the line who notices a small inefficiency does not file a suggestion and wait for a committee. They form a hypothesis, test a small change, check the result, and adjust. Multiply that by tens of thousands of workers running small experiments every day, and the result is an organization continuously tuning itself at a resolution no top-down redesign could ever match. All three examples point to the same underlying move: reduce the cost of being wrong. When a failed test costs an afternoon and a few dollars of cardboard instead of a quarter and a department's credibility, people run far more of them, and the organization learns far faster. So again, we see experimentation is a large part of improvement as well. Phase 3 is what we would call optimization and fine-tuning. When a low-resolution test succeeds, it graduates. It becomes part of the standard operating procedure. The new default process, the new product feature, the new team structure, this is where a subtle mistake often creeps in treating that graduation as the finish line. This happens so often, right? As we say, hey, we made an improvement, and then we're on to the next project. Systems thinking rejects that idea outright. Every optimization locked in becomes the new current state, which is itself just the starting point of the next round of phase 1 observation. Toyota treats the target condition as a moving one for good reason. The system tuned last quarter is not the system in place today. New people, new tools, and new market pressures have already begun to shift it. Amazon has arguably institutionalized this better than almost any other large company. Its continuous A/B testing means thousands of small experiments run across the business at any given time. Each one a phase 2 test feeding back into phase 3 tuning, right? So we've essentially created these big improvements. We know what the thing is that we need to do. Now we just need to tweak it, make sure it's absolutely perfect, make sure it's optimized to whatever it is we're doing. I've noticed on Substack, by the way, that there's a lot against optimization culture. And I think part of it is because we really don't understand the role of optimization in improvement and in organizational performance. Underneath that testing culture sits a decision making framework Bezos laid out in his 2015 shareholder letter, distinguishing one way door decisions, which are hard to reverse and warrant slow, careful deliberation, from two-way door decisions, which are reversible and should be made quickly by people close to the work. Bezos' own warning is instructive. As organizations grow, they tend to apply the heavyweight, one-way door process to everything, including decisions that are actually quite reversible. And the result is slowness, risk aversion, and diminished experimentation. Experimentation is the name of the game, after all. Naming which kind of door a decision represents is itself a piece of organizational infrastructure that keeps the experimentation cycle running instead of grinding to a halt under its caution. 3M shows what happens when an organization protects the time for experimentation rather than the only process. Its long-standing policy of letting employees spend a portion of their time on self-directed projects produced the Post-it note after Spencer Silver's low-tack adhesive sat unused for years until Art Fry found a problem it had happened to solve. Phase 2 experiments do not always resolve on the timeline anyone would prefer. Sometimes the tuning happens not in the next quarter, but the next decade, and the organizations that benefit are the ones that kept the door open long enough for the right problem to walk through it. Intuit's Design for Delight program pushes the cycle back toward the customer directly, running fast, low-cost experiments with real users before the company commits significant engineering resources to a product direction. It compresses phase 1 and 2 into a quick, repeatable loop. Observe the customer's actual behavior, prototype a response cheaply, and only scale what survives contact with reality. We sometimes call this ethnography. This is a big part of human-centered design. Variation is information, not failure. It is worth returning to the point we made earlier because it is a piece most cultures accept in theory and abandon in practice. When an experiment does not produce the predicted result, the gap between prediction and observation is exactly where learning occurs. An organization that punishes surprising results teaches its people to stop running experiments that might surprise anyone, which in a complex system is most of them. I will also say from my experiences, what I see is lots of failures being turned into successes rather than just accepting them as failures, but learning from them. The point of a test is not to be proven right. It is to close the gap between the model of the system in a manager's head and the system as it actually behaves. I wrote a previous article about the conceptual organization versus the real organization. So check that out. It's getting exactly to this point. And a well-run test does that, whether it confirms the hypothesis or demolishes it. And again, one of the things that I want to say here is if we are focused on knowledge management and becoming a learning organization, this becomes much easier because we're rewarding knowledge gained rather than very, very small performance lost. Everyone's not being defensive and risk adverse because we're all in this together trying to gain knowledge. So here are some takeaways from managers. I'm trying to be a little bit more practical at the end of some of my articles so that people who are reading this, who might want to try to apply it to businesses immediately, can take something away with it. So again, I would love your feedback. Let me know if this is something you enjoy or not. Takeaways for managers. Start with observation, not solutions. Before approving a redesign, insist on a current state map, real cycle times, handoffs, variation. A team that cannot describe how work actually flows is not ready to change it. Shrink the cost of being wrong. For an initiative, ask what the cheapest version of it would look like tested in a week. If the honest answer is 6 months and a cross-functioning steering committee, this is not an experiment being designed. It is a bet, and it deserves the scrutiny of one. Sort decisions by reversibility before sorting them by importance. We can borrow the DOOR framework from Amazon. Reversible decisions should move fast and get delegated to people close to the work. Irreversible ones deserve the slow, careful process we call bureaucracy. Treating every decision like a one-way door is one of the most common ways organizations stop experimenting. Protect time and slack from undirected experiments. Not every useful test comes from a roadmap, like we saw in 3M and Skunkworks. Organizational insulation both worked because they created space outside the normal approval chain. Treat every finished project as next quarter's current state. Build a review of an optimization's results directly into the next planning cycle rather than treating success as a reason to move on. The system that improved is not the system that will still be optimal a year from now. Someone has to keep watching it. The system is always talking. This is kind of the final idea. Complex systems do not come with a manual. They only reveal what they are through what happens when someone pushes on them. And they keep revealing it indefinitely because they keep changing. Organizations that treat experimentation as a quarterly initiative are listening to the system in short bursts and hoping nothing important happens in between. Organizations that treat it as daily practice, a habit of observation, cheap testing, and continuous tuning are the ones that actually keep pace with a system that never holds still. The lessons from IDEO's cardboard prototypes, Johnson's circus tent, Toyota's daily kata, Amazon's two-way doors, 3M's protected times, and Intuit's customer tests is not the same single method is the right one. It is that all of them made experimentation cheap, frequent, and structurally unavoidable, an operating system running underneath the strategy rather than a project sitting on top of it. As always, that's the end of the article. It was free. So was this read along. So please subscribe to Systems of Human Performance, leave a comment, and if you would, find one person in your network who you think might enjoy this and share Systems of Human Performance. As always, I really appreciate everybody who's tuned in and subscribed. If you'd like to support me, please become a paid subscriber on Substack. If you don't want to be a paid subscriber, you still want to support me a little bit, or you want some more information on what I do, I've recently published a book titled Man and Machine, which is a guide to designing efficient, productive, and humane technological systems. You can find that book very reasonably priced on Amazon in a print, paperback, or ebook editions. So please, if you're interested in that, if you're interested more in human system design, that is the book for you. I think it's the best one on the market. So as ever, thanks for tuning in and appreciate the support.